So which one of the following lines is parallel to the line 6x minus y equal to 10? So first thing is that everything is in R2. So that is something that you should keep in mind. In R2, that is the only space for which the lines have both parametric equation and standard form equation. So from this guy, you notice that the normal vector, so let me call this one as line 1. The normal vector to line 1 is going to be take the coefficient of x and coefficient of y. That is the normal. Okay. And we know that two lines are parallel, so are supposed to be parallel. So L1 is equal to L2. This implies that they share normal vectors. So if you have normal vector for one of them, the other one has this, can have the same normal vector, and they share the parallel vectors. Okay, so in this case, right away we can go from there and say that, okay, normal vector for the second vector is going to be, for the second line, is going to be, can be taken to be exactly same thing, 6 and negative. Well, so far everything is good, but when you look at the answers are given in the parametric form. So we need to determine what could be a parallel vector for L2. Well, what is the information we have? Knowing that it has 6 and negative 1 as its normal, as a normal vector. So now I am looking for a line whose normal vector I know what is, and I'm looking for a parallel vector for that. Well, this is another fact that you probably need to know, that parallel vector and normal vectors are always orthogonal to each other. So if this is Vn, we are talking about one line, the normal vector and parallel vectors of the same line are perpendicular to each other. So then parallel vector here, then parallel vector for this line that we are studying is a vector which is orthogonal to N2, which is 6 and negative. So I have to come up with a vector which is orthogonal to this 6 and negative 1. There are infinitely many ways you can do this, but one of the ways that you always do in R2 is that if you have components of two vector, you interchange the components and multiply one of them by negative sign, either the first one or the second one. This way, you generate, these are going to be orthogonal to AB, the original one. So we will apply that one here. So V2 can be either negative times negative 1, 6. So interchange these two, multiply first one by negative, or it can be negative 1 and negative 6. So this guy here is 1 and 6, or negative 1 and negative 6. Okay, with these all information in hand, now we go and try to see if we have any of these equation with a vector which is this or any other vector which are which are parallel to these vectors. So just by looking at these guys here, the first vector is definitely not parallel to that 1 and 6. The second, well, the third one is not. We have to check now if this is true for either the first one, third one, or the last one. Well, I can see that if I multiply this vector by 2, I get 2 and 12. So this vector has a parallel vector which is parallel to the given vector that we found. So this will be what we were looking for. And that's the only one. Everything else, if you multiply 1, 6 by any of these numbers, you won't get neither this one nor that one. Any question, any comments here?